Hello, in this lesson we're going to learn about congruent triangles, how to tell if two triangles are congruent to each other. So I will start with the title of our lesson, which is Congruent Triangles. And let's go ahead and start recording the notes for this. It says sometimes you want to determine if two triangles are congruent. To determine if two triangles are congruent, you will need
Mr. Rader, report to front office. Mr. Rader, report to front office, please.
You will need to know some important information about the angle measures and the side lengths of both triangles. These are the triangle congruent shortcuts. Okay, so they are side, 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 angle, side, angle, 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 side, and hypotenuse leg. All right, so underneath are a bunch of examples, and this is how you're going to learn to understand which ones are side, 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 and all of these other options is by seeing a bunch of examples. So let's start with the directions that say, state whether each pair of triangles is congruent by side, 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 angle, side, and so on, or are they not congruent? If the triangles are congruent, we're going to write a congruence statement. So the first thing we're going to do is we're going to look at these two triangles that are put together, and we are going to put a marking on side CB. We're actually going to put 3 lines, and those 3 lines tell us that CB is congruent to itself. That's called the reflexive property, and the reason why we put that marking is because CB is a shared side. The two triangles have this side, so because they share it, I want to say that it's congruent to itself. And then when I look at the 3 triangles, I see, or 2 triangles, I see that all 3 sides have markings on both triangles. And that means that they're exactly the same. They're congruent by side, 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 because this side is congruent to this one, AB is congruent to CD, and BC is congruent to itself. So they're congruent by side, side, side. And then we can say that triangle ABC, I'm going to fill this in, is congruent to triangle DCB. So we have to match up the sides. A and A, or the angles, excuse me, A and D match up. That's why both of these angles come first. B and C appear to be the same measures. D and C, and then B and C appear to be the same angle measures. All right, let's look at another example. Example 2 has vertical angles. So I'm going to mark those with 2 curved marks like this. Okay, because vertical angles are congruent. And then I'm going to look and see, kind of in like a circular motion, which angles are congruent and which sides are congruent. So I'll start on this edge, angle and a side, and then an angle with 2 markings. And on the other triangle, there's an angle with 1 marking, a side, and an angle with 2 markings, all in a row. And this is called angle, side, angle. It's really important that the side is directly in between these 2 angles, and we have that. Okay, so we are going to write a congruent statement. We've got triangle ACG is congruent. If we started with If we started with A having a mark on it, we need to start with angle B on the other triangle. Angle C is in the middle, and angle C is congruent on the other triangle. And the only angle left is F. Okay. Then let's look at example 3. I see one marking on an angle, two markings on a side, and two markings on an angle. And if I look at the other triangle, I have one marking followed by two on the other. The markings line up in the same way. They're just kind of turned around, and that's okay. So we're going to say this is angle side angle just like the last one. It's very important for angle side angle that the side be in between the two angles, directly in between. Okay, so I'm going to say that the triangles are congruent, and now I'm going to write a congruent statement. So I'm going to look to see what I want to call this. How about MLN? Angle M had one marking, and so does angle O. Angle L had two, and so does P. And then S is the only angle left. Okay, so that was the first 3 examples. We actually have 6 more we're going to look at. All right, here's the next one. Okay, I'm going to mark the vertical angles being congruent to each other. All right, and then I'm going to say, okay, what do I see? I see an angle, and a side. The first angle has 1 marking, this one has 2, and this side has 1 marking. The first angle on the other has 1 marking, and then 2, and then a side with 1 marking. This is called angle, angle, side. I have angle, and side. If you did this and you saw side, angle, angle, well, that's just angle, angle, side backwards, and we don't use side, angle, angle. We like it to be angle, angle, side. Okay? All right, and we're going to name these. Triangle AEB is the first one. Okay, A has no markings on it, and neither does D, angle D. E has 2 markings on it, and so does angle E on the other one. And angle B has 1 marking, and so does C on this other triangle. Okay, on the next example, I have a side that's shared. It's AC. So I'm going to put 1 marking on it to show that it is congruent to itself by the reflexive property. So I see that I have a side, an angle, and then a side with 2 markings on it. And when I look at the other triangle, I see a side, an angle with 1 marking, and a side with 2. So this is side, angle, side. It's extremely important for side, angle, side that the angle be in between the 2 sides, directly in between. Okay? And let's write a congruent statement. Triangle ABC is congruent to triangle. A had 1 marking, and so does this A. B has nothing, but it's an obtuse angle, and so is E. And C is this smaller acute angle. Okay, so ABC is congruent to triangle AEC. Okay, here's another example. This has an angle and a side with 2 markings, an angle and a side with 2 markings. Unfortunately, there's not enough information. So these are not congruent. It doesn't really matter that they sort of look congruent. What matters is I don't have enough information to say they are, so I say that they're not. All right, let's look at example 7. Okay, on example 7, I've got 2 right triangles. I think this is the first example where we see two right triangles. The second thing I see is that the hypotenuses, which are across from the right angles, are congruent. They both have 3 markings on them. And then I also see that there's a pair of legs that are congruent to each other. So for hypotenuse leg, I have to have right triangles, I have to have hypotenuses, and then I have to have a pair of legs that are congruent. And I have all of that. So these are congruent by hypotenuse leg. Okay, and I'm going to say that triangle CDE is congruent to triangle B, because angle C has a right angle and so does B. Angle D is this wider acute angle and so is A. And the last one is E, is this really small acute angle, and that's F. It matches up with F. They're corresponding angles. All right, we have 2 more examples. On example 8, I see that both triangles have an angle on the left with 1 marking, an angle on the top with 2, and an angle on the right with 3 markings. So I would be tempted to call this angle, angle, angle. Unfortunately, that's not a reason for triangles to be congruent, because this triangle might be ever so slightly larger or smaller than the one on the left. There's just no way of knowing unless they give us a side measure, which they don't. So we're going to say that there's not enough information, which means they're not congruent. And here's the last one. On the last example, I have an angle that's right and another angle that's right, because these are vertical angles, so they're both right angles. I also see that I have hypotenuses that are congruent and a pair of legs that are congruent. So I have enough information to call this hypotenuse leg, and I'm going to say triangle EGH is the first triangle. Triangle EGH is congruent to, well, since angle E is next to the side that has 1 marking, I need to start with angle I on this one. IGF. All right, that's it for us. Thank you so much for watching.